Thank you very much for coming. So I'm Diego Ferreira-Val. I work for Salesforce. I'm the lead UI and web performance engineer. And since it's my first time at Velocity, I thought I might want to share some background. As you can see from my accent, I know from around here. I'm from Spain. Just to let you know, Madrid is more than, Spain is more than Madrid and Barcelona, right? I come from this little northwest part above Portugal. And no, we don't do bullfighting. We don't eat paella all day. But we do have a lot of amazing food. So I encourage you, if you go to Velocity Barcelona, you might want to go ahead all the north and try this amazing food. And also, we have this amazing, I think I forgot. I think I'm going to start with the presentation. So we're going to talk here about how we can build really performant UI components. And as you all know, the GPU plays a really important role here, right? So we're going to see one particular example, and hopefully you guys can extrapolate what we're talking to whatever component you guys are building. So as Paul Lewis, Paul Iris, they have really good articles on performance, how each of the steps that the browser needs to render. So I'm going to assume that you guys are fully familiar with this to understand like the last part of the talk. If not, you can just read about it later and go over the slides. So we're going to focus here on one component, which I think is pretty interesting, which is a scroller, right? And if we're all here, it's because you're kind of like interested in how that works, right? So everything started at Salesforce. We have this mobile application we call it Salesforce One, and we basically allow the customers to customize pretty much everything, right? Which means that we end up with really gigantic, large scrollable areas. We have nested scrollers. We have a pretty complicated, basically DOM to render, right? So we look at all the scrollers that are there, and there was nothing really that could benefit what we want to do, right? So this is how everything started. So I put a couple of prototypes a long time ago on Twitter, and the first comment I got was, hey, you know that you actually can scroll using CSS. And if it were that easy, it wouldn't be here, right? So the first thing I took is basically what is the native CSS scrolling give us, right? And it's the most, let's say, performant because it's as close to the browser, and this is pretty much the best we can get. But there's certain difference, right? For example, there's difference between different platforms. Some platform has bouncing, some platform does a different bouncing, exponential decay. Windows have one type, iOS has another type. But more than this subtle difference, there's a couple of interesting problems with the native scrolling. And so those are the problems we're going to try to solve in this talk. So to just cover a little bit quickly, so for example, we don't have control over the animation, right? As we scroll, we don't have just any browser event that tells us, hey, we're scrolling, we're in this position. We just get one at the end, which tells us where we are. There's no room for customization, right? We all love like the native would refresh, put a little more, so we cannot do that with native. There's a couple of sections, and there's a lot of inconsistencies, right? So if you prevent defaults in iOS, it will just not scroll. Nested scroller will behave oddly, and a bunch of other sort of problems. And the main one, and which is the one that I think is the more critical one, is the bigger the DOM and the large our DOM and the scroller area gets, the complicated and more work the browser has to do to paint it. And we're going to see flickering. We're going to see a bunch of other, a lot of problems just because of that. So we're going to try to solve pretty much everything building a synthetic scroller, right? So we're going to build a JavaScript scroller that's going to allow us to solve all these problems. We're going to see all the research and all the work that I did for ThinkConvert in that. So I'm going to cover really quickly what is the basic of scrolling. And basically this implementation is using CSS transition, and this is what you're going to get with pretty much all the scrollers that are out there. For example, iScroll, FT Scroller. If you go to Google, the scroller that I have in Gmail, so all are using this technique. And basically this technique is fairly simple. We get a gesture start, whether it's a mouse event, a touch start, or a pointer event. We just get some states inside the scroller, and then we start moving our finger, and basically we translate 3D the scroller, the content, right? So, and we know that we want to do translate 3D because that promotes the layer to a GPU, and GPU is really good at moving pixels on the screen. We all know that, right? So once we finish, we actually have to calculate the velocity, and given that velocity, we can calculate what I call the momentum, right? Where we're going to scroll to, and how long this scroll how much time it will take to do that scroll, right? And so they apply a transition, which is in this case a cubic Bezier curve, and we're going to go in deep into how all these calculations work and why we use cubic Bezier and how that works. And basically, we just check its valid position as we scroll, and then we clean the transition afterward. So this is an example. I did it overflow on purpose so you guys can see what it will actually look like. And so as you can see here, we get the velocity, we get the destination where we're going to scroll to, and we get the duration, right? And so this basically translates to the CSS property, which is to relate 3D to that position in that duration, and using this animation function, which is the cubic Bezier curve, we can define, right? So this is what is right now implemented by pretty much all the scrollers that are out there. So that solves two problems. That solves that we have basically one scroller that works pretty much across every platform in the same way, and we are able now to pull to refresh, do snapping, things like that. So I'm going to show you a really quick example. So this is basically the scroller using pull to refresh, and it's using the stuff that we just talked about, nothing really fancy. We're going to do a lot of demos as we speak. So that's good, but that's not enough. It's not solving the complicated problem. We're still not able to fetch dynamic data, right? We're going to be able to show, as I scroll, I want to be able to fetch images or load more content. So we still cannot do that with this implementation. So this is where we're going to the math world and understanding how a scroller works in order to solve these other two problems. So as probably all you know, behind every animation, there's an amazing mathematical formula behind. So we're going to go a little bit into the math world. I'm going to put a couple of formulas so you guys can take a look later after the talk, but I'm going to cover a little bit how that works. So the first thing we need to do is calculate the velocity, and that can have quite an impact on performance, right? So if you imagine as we scroll with our finger, we basically need to somewhat understand what the user intent was to do, because it can go up and down, and we just care about the final velocity given all the stuff that he did, right? So in order to do that, those two equations are the kinematic equations. Don't worry about them. The only thing we need to know is the velocity. Given the velocity, we just can get the time, the duration, everything we want. And at the end of the day, velocity is the difference between the current position previous to the last position divided by the current time difference the previous time, right? So as you imagine, as we scroll, we need to somewhat sample, right, the gesture we're doing and calculating the diffs and somewhat average all that. So in order to do that, we're going to use another equation, which is called exponential moving average. And what it's going to do is basically smooth out, right, the gesture, right? As you scroll up and down, it's kind of a smart median, right? Smart average, which is going to tell us efficiently where we're scrolling. The most fundamental part for performance is we're going to use request animation frame not only for calculating the frame velocity at each time, but actually to decouple and debounce the event from the animation. Because if you think about it, the browser will give us actually more frames and more events that we actually need. For example, you can think in a second we might have 120 events, the gesture move, but we actually need just 60, right? So this is something that Paul Lewis has been talking for quite a long time, which is the bounce in the event for animation give us a little bit of performance boost. And on top of that, we're going to use the request animation frame to calculate the deltas and the velocity. So the result basically is this. As you can see here, we're using request animation frame to get the frames to update the DOM. So we don't just update it every time we move it. We update it at every tick that the request animation frame does. And the velocity here is pretty accurate, right? So you can see here, minus 1 pixel millisecond. If you go up, it's negative. If we go down, it's positive. So that's we get an improvement in performance is because we're decoupling the event from the animation. And that's one of the things that is pretty good. Now, once we know the velocity, we calculate the momentum, which is, all right, I need to scroll to the pixel 500, and I need to do it in 3 seconds, right? So now we need to actually interpolate that and go there in a particular moment in time. And this is where the easing function comes in play. And as we saw before, there's the cubic Bezier curve that's going to be the animation that we do as we scroll. So if we go to the physics world, the real equation that we use is this one. And this is a real nice article by Arya that explains a little bit in deep this. But it's basically an exponential decay function, and that will give us the real physics of the deceleration curve, right? The interesting part of this is we don't want that level of detail because we don't care really if we're in the pixel 24.71 or 24.72. So we're going to approximate that exponential curve to the cubic Bezier. So the cubic Bezier curves is basically you define a curve given these 4 points, and those 4 points are going to define the animation function that you're going to do. So just modifying the points, you're going to get pretty much the same curve that we had before. So if I play this again, you will see that the curve is fairly the same. So we can approximate the real physics curves by using cubic Bezier. And it's much easier to tweak, right? Just modifying these 2 points here, right? As we change the points, we're changing effectively the curve, right? So we're going to provide this curve to the scroller. We're going to say, right, I'm going to scroll to the position 250 in 5 seconds, and this is the curve that I'm going to use to interpolate. So as you can see here, the x is being slower as we arrive to the end, which is what we're going to do as we scroll, right? When we scroll, at the end, we're going to have these events of deceleration, right? So this is why we're going to use the cubic Bezier. But the difference is that now we're going to implement in JavaScript the cubic Bezier function. And the reason is because we're going to be able to control at every point in time where the scroller is. So we're going to do, again, the same trick. We're going to just request animation frame for updating the scroller as we go. So this is a glimpse of the function that does the scrolling. So we basically say, all right, you need to scroll to position X in this amount of time with this curve. And what we're going to do effectively is actually just request animation frame and ask at each frame to the curve, all right, so give me the position where I should be in this point in time, which is the line that you have there. And basically, we update the position, and that's it. So the interesting part of this is not only that we can have now the velocity and the position at every point in time, sorry, not the velocity, the position. So you can see here, now we control at every point in time where we are at. So, and what is interesting is now we can decide, as we're scrolling, am I arriving to the end, so am I going to fetch some data? Am I going to do something else? So maybe you will say, all right, so you implemented cubic Bezier curves on the browser, all this craziness, so is that so important? So the important thing about this is you're going to allow us to fix the last big problem. So the main problem that is remaining is we still have this gigantic area that needs to be rendered, and every time we touch, it's going to have a big process and a big impact on what the browser works, right? So we're going to try to solve the last problem now, and we'll have all this infrastructure done. So if you think about it, we have this gigantic scrollable area. In this case, for example, it's 320 pixels by 33,000. And that's quite a long surface to send to the GPU to render. So devices, for example, that are either not utilizing the GPU as much or that they are less capable, like, for example, Firefox OS, they're not going to render as perfectly as, an iOS or Android with 4.4, right? So we're going to see some choppiness, right? You're going to be like, we're losing frames. And the reason is because the browser is not able to move that gigantic surface across the frames, right? So we're going to introduce one little piece of code, what I like to call Surface Manager. So think about Surface Manager as a proxy between the DOM and the browser and the user, right? So as the user scroll, instead of manipulate at any point the DOM, the Surface Manager will take care of it. And the most fundamental part of the Surface Manager is what I call surface. So think about, you have your scroller there, which is a gigantic region. So what we're going to actually do is split that scroller in small pieces, what I call surfaces. Those small pieces are basically 3D accelerated, and basically they're send it to the GPU, and at that point on, those surfaces are really cheap to move. So I'm going to do a really quick demo here as well. So using the Chrome Canary, the tracing tools. So this is basically the how it looks, the bad part. This is basically the GPU view of how it looks on the screen, right? So you see it's a gigantic area here. And we can just inspect and see that there's 33,000 wide, right? So what we're going to do effectively, just using the surface and translate through every little piece, is actually effectively dividing the regions in sub-regions. And we're going to see what is the benefit of that. So more than just splitting that, we cannot, let's say we have 100 items, and we put all these 100 items in Surface Manager, then we're going to have another problem, which is the GPU will not be able to, render all these 100 items at the same time. So what we're actually going to do is the Surface Manager is going to take care of replacing the touching and attaching to the DOM when necessary. So as I'm scrolling, the Surface Manager, remember now we have control of every frame when we're moving. So as we're scrolling, the Surface Manager is going to do is like, oh, I don't need item 1 anymore. So it's going to detach it from the DOM, and use the surface to touch something else at the end. So as you can see here, at any point in time, we just have a regular fixed size of DOM at any point in time. And I'm going to do another demo really quickly here, how that looks on the browser. So as you can see here, I have like around 250 or 300 items. And as you can see here, we have the surfaces here. This is what you talk about. And those surfaces are GPU accelerated. So I scroll, you see this push and shift debugging. We're just moving the surfaces on the DOM. So any particular point in time, even if we have 100,000 items on the DOM, only 6 of them are going to be present at every particular point in time. So as you can see here, we still have 60 frames per second, and now we can handle as many DOM elements as we want. And interesting enough, the performance is much better. So this is not magic, right? So let me explain exactly how this works. So the way it works is actually the most complicated part is when we actually touch the DOM. So as long as we don't touch the DOM, we're good. So when we actually effectively have to say, all right, I need this item here because the user is scrolling, we actually effectively have to attach it to the DOM. And this process is the most costly one. So when we append something to the DOM, automatically we're going to get a recalculated styles. And that's normally pretty cheap, right? It's going to take not even a millisecond. And now the other expensive part is the paint. But if you think about it now, we're attaching something into the surface accelerated area. So instead of painting the whole thing, we're just constraining the paint to this little sandbox, which in this case is going to be around 320 by 150 pixels, which is going to be really cheap. So if you profile this again, and we go to the timeline, you're going to see that there's a really small paints that happen from time to time. Right? But you see, we're really, really below 60 frames per second. So the time we're spending on painting is so small, that the browser doesn't even care about. So we're going to focus here, and we're going to go to find a paint. So you can see here, the paint was really, really small. Actually, it didn't even took a millisecond to render. So this is how we're going to this is how we're able to now control what happens every frame. Let's say that we want to, load more data as we're scrolling. Let's say we're going to actually, change some DOM elements. So we are actually not touching the DOM. The surface manager is touching it for you when necessary. So the performance keeps linear as the amount of the elements that we add keeps growing. So what is interesting about this is that the way this color is implemented is that it's plugin based, right? So all the stuff that you saw, the pull to load more, pull to refresh, surface manager, there are like small plugins that are on top of the core code that scrolls, right? So for example, my idea was to create some sort of like a system where actually we can add plugins to it, and it will still have the core and surface manager working, and we can do pretty much whatever we want on top of that. So this is an example how we can actually listen for events. For example, the scroller will fire an event saying, hey, I'm doing a frame and updating my position, so if you want to do something, just do it here. So more than just talking out the code, and which the slides are going to be available later, I want to talk about some examples, and you actually can see the power of this scroller. So we saw the GPU optimization. We're going to do something fancy. We're going to do basically loading from Flickr dynamically. The connection is not going to be helping us much, but we can just load stuff as we scroll, and the performance is keeping pretty good. So one of the things that really what people love is animations and transitions and Trailer 3D. So what if we can just build a plugin using all this infrastructure that allow us to do anything we want? So for example, this is what I call an FX endless plugin. And so as simple as just modifying at every point in time the surfaces, we can just do whatever we want. It's up to you guys to decide what you guys want to do. So 60 frames per second, you can try it in Windows Phone, Firefox OS, pretty much works everywhere. And so there's no magic. What we did is basically understand the browser and see how we can, I think I clicked too fast, but that's okay. It will stop at some point, but hopefully it will stop, right? All right. So, for example, you can build plugins to basically do an infinite list, right? I think I have some here. Let me see really quick. Basically, endless, right? So we have 15 items, and what we do is we swap them, and we say, right, so it's the last one, so I'm going to just keep on scrolling with the first one. So these are 15, but it's an endless scroller. So the possibilities are endless once you understand the problem, once you understand what the browser is doing underneath. So to give you an example, I have here this code here. Let's go back. All right, so I'm going to show you really quick the code. So this will be like a plugin, right? A plugin will be injecting itself inside the scroller, and it can override functions and listen to functions. So what you can effectively do is like, all right, so for the surfaces that are available, I want to change the matrix, which change the, the shape. And for example, just modifying one line, we just have, a fancy animation here. And this is 50 lines of code. So now you guys might be wondering, that seems pretty cool. I would like to play with it. So what if this was available today? So I'm happy to announce that today I'm open sourcing Scholar.js. So I hope you guys like it. There's basically all the documentation is in there. I'm still working on it. All the plugins are here. You can play with them. You can basically try on your iPhone. There's some gyroscope demos that are pretty cool. And the idea is that, since I solve, I think, one interesting problem, just share it with you and see what plugins you guys can come up with, and so insert those plugins also in the open source community. So, just to finalize the talk, I just wanted to mention this quote from Adios Manik, which I really like, and is everything we do impacts performance. So, and I've seen a lot of people, with Famous and all these amazing, libraries that are coming, hearing here like, oh yeah, Famous is 10 times faster, or this framework is so amazing. Like, I want to know this magic because I don't know it, right? So at the end of the day, I think the message I want to give to everyone is everything you do matters, right? And every piece of magic, in performance, there's no magic, right? You need to understand what really is happening. So no library is going to save you for understanding what the browser is doing, the rendering cycle, and how to optimize the page. So once you get a framework, once you get something that is doing some fancy animation, just profile it and make sure that it performs correctly and it works for you. So with that, I think I'm done. I have an office hours because probably you guys are going to have a lot of questions if you try it out. I'm going to be here all these days. If you guys want to have any questions, I will be happy to answer. And I hope you find useful the library and you guys can use it for your own products. Thank you. I don't know if we have time for questions. I cannot run always when I want to speak. So if you guys have any questions, I will be happy to answer them now or later. Yes.
How old does it work on older browsers? i7 and 8?
So that's a compromise, right? If sorry. Yeah. What is the matrix compatibility basically, right? So depends on which plugins and which options you're using. If your browser supports Translate 3D or transformation, it will work. For example, Windows Phone does not support nested matrix 3D. So there's some plugins that might not work just because of that. And depending on the options that you put to the scroller, it might work or not. So there's a fallback. I'm not quite sure if I did test this everywhere, but not in all the branches of IE. So I think it will be pretty trivial actually to get support to i7 just using the left top position, which is going to be pretty bad for performance, but it will work, right? So if it's not there, just open an issue or like pull request will welcome, and we just support it pretty quickly. Questions? More questions somewhere? All right. So I hope I see someone in the office booth. So thank you.